Right, welcome to this session of the Beauty Conservation Society. With both myself and Doron Swade, it's liable to be completely unstructured, but we'll do our best to put some sort of order onto it. There is one notice, and that is that we would like to go down to Sugo's after this meeting. So those of you who wish to join us for a relatively cheapo Italian nosh are welcome to come down. It's circa £12 a head. It's creeping up a bit, but it's circa that. So just follow somebody who knows the way if you want to come for a meal afterwards. Right, I'll introduce Doron, then Doron will introduce me. Right. Go ahead.
Okay.
Zero something. You've got to get plugged in.
It's really working. Yeah. Ah, right. Okay, this isn't a lecture. It's a set of considerations, if you like, that grew out of Computer Conservation Society activity. And it seems that there are several communities. I mean, the idea was that actually we'd have a curatorial community here, we'd have computer conservation. Is that a lot of the activities of the CCS seem to be stressing conventional museological criteria. There seem to be two issues going. One is the issue of simulation and emulation. That is the idea of building logical replicas of machines. And that raises a whole pile of issues which perhaps aren't fully appreciated by the CCS in terms of the extent to which they are radical and possibly even heretical in traditional museum culture. For example, if people build a physical replica, you can only incorporate in a physical replica the kinds of predicates, the kind of understanding of the original object that you have at the time. In other words, to take an example, if we built a replica of Faraday's workbench, and we had no idea that Faraday was being poisoned by any of the materials he worked with, we would not think of putting mercury in the bench. It is something that would be unforeseen at the time we built Faraday's replica. The point about it is if a toxicologist subsequently had a theory about Faraday's aberrations, illnesses, being a result of being poisoned by the materials he's been working with, it would make sense to examine the original replica. In other words, the original artifact is regarded in object-centered museum culture as the ultimate authority. You could interrogate the workbench for traces of mercury. So, in other words, in museological terms, replicas have a limited value in respect of historical authority. Now, the question is, if we build a logical replica of a machine, we're saying, in Turing's terms, what the machine is its logical description. In other words, can we interrogate a logical replica, that is an emulation or a simulation, in a way that would allow us to interrogate it in an open-ended way? And with logical replicas, in museological terms, distinct from physical replicas. Now, clearly, people know their machines in the way they know people, through mannerism, through characteristics, and through quirk. We're not going to replicate that on a simulation. What I'm waving to on the left here is a simulation done by the CCS, by Chris, by the Pegasus workflow to some extent, of Pegasus. That's a big machine. Tony's going to talk about it. What I'm pointing to here is a picture, a simulation of the control panel of Pegasus, which is sitting running live, not right now, but can be out in the hut at the back. So one set of issues that the CCS activities seem to have agitated, if you like, was how do we absorb, if you like, into our summative world something which seems to be new, the idea of using a perfect replica of a logic machine in the sense that it's unlike a replica of a steam engine. The second set of issues is a set of philosophical and practical issues about software. And the problem of software has been kicking around for a fair amount of time. Now, there's a serious problem about the communities of people with whom for whom this problem is pressing. I spoke to Tony earlier in the week and he said the problem's been cracked. I mean, we've done it. There are people sitting in back rooms, CCS, computer buffs, who actually can see the kinds of technical solutions, the kinds of things you would need to do, and the kinds of problematic areas of preserving software. Do we need operational continuity? Does software have any meaning outside the context of operational hardware? All these issues. Now, what happens inevitably is you get into some sort of omelette. Inevitably, there is a series of yes-but arguments. One says, yes, you need the original medium intact. it is perfectly obvious. A computer person would look at you with complete incomprehension if you walked up to him and said, did you know that magnetic media were impermanent? The reason for his incomprehension would be, it is part of his assumptive world. It would be inconceivable that he would actually need to say anything like that because he would know it. It's part of his tacit knowledge. In conversation with the curator last week, it became evident that they were not clear that magnetic media are impermanent. So on the one hand, we have the stirrings to actually create a software archive of some kind, to preserve software. On the other hand, we have the traditional museological, object-based culture, which actually technically has very little perception or insight into the technical implications, but at the same token, the computer tribe has very little understanding, if you like, of the museological implications. So, because there were supposedly supposed to be two complete communities here, and because tonight happens to coincide with the launch of our corporate scheme, which means most of our senior curators at St. James Palace, there are in fact a smaller sprinkling of curators than might otherwise be the case. But the point is actually, what we're trying to do is actually translate and start a dialogue between two communities. So inevitably, the things I will say about computers might sound monstrously trivial to computer people. Equally, I mean, computer people have a sort of implicit vocabulary. They know about BIOS, DOS, and virtual memory. You'd say that curators know about social constructivism and material culture. I mean, I hope they do, perhaps they don't. I mean, those are different languages, those are different mindsets. Another thing curators know is about floor loading, and that's perhaps common ground. Because floor loading is the one thing that is always, no project has a floor loading, no matter what it is. It could be a feather, but floor loading is a problem. So what I'm trying to do in a sense is, various people have looked at the problem, archivists have looked at the problem. Computer conservation, we set up a software working party under Martin Campbell Kelly, which did very useful work, and came to some very significant conclusions. There's a major report, which is that thing, 1987, the date is quite curious. That's a 79-page report, and that will give some indication of just the complexity, why it is you get into this yes-but argument. If we try and preserve software, we need to keep operational hardware. If we can't guarantee continuity of operational hardware, so we'll transfer the medium. One is impermanence mean, we'll transfer the software. Then you say, but hang on, you need the synchronous, the contemporary support document, you need operating systems. What about the patches? Will it run in the operating environment with that particular release? A whole pile of questions come up. Then you say, well, okay, let's preserve the data so we can interrogate it in an open-ended way. There's this intellectual salad that results, which never gets resolved. And reading that report will become evident why. There's something like 9 different dimensional criteria which will characterize software. So I'm not for a moment proposing that we crack the problem or that the solutions are clear. But what does need to be done, what does need doing, that is articulating the museum's position. The museum is an object-centered culture. It seems that software, which is the second issue, violates some of the traditional criteria, that there's something abstract about software. What is important about it is its relations and not its physical medium. And it seems that there are a whole set of museological issues. So, instead of actually solving the practical issues of software, which, I mean, people have been around the block, and people in this room have been around the block with that issue, what I'm going to do is actually do some curatorial agonizing, just to give some feel for the kinds of things we would need to do in order to justify a full program of software archive. In other words, if ever, there was at some point, there was not a national film archive, at some point there was not a sound archive. Somebody cared enough to make representations to the powers that be, to extend our material culture, what it is we perceive to be worth keeping, to incorporate these things. And the question is, if ever there is a computer archive, if ever we can decide what such an archive might be and who it would serve, we would need to make very articulate representations to the existing custodial body, which are the National Museums, and our masters, to be quite clear as to why it is we would need to extend the resources from an object-centered culture to something like software. The question is software a conventional material object? If it is, we have no problem. We just extend the magnificent resource of the Science Museum, £20 million a year, and the fact that we don't need to justify why it is we keep physical things. There are any number of reasons, and learned articles and books are written about this. Some of it's to do with immortality, some of it is to do with the fact that we want to retain physical symbols of our most meaningful personal experiences. There's a whole host of things. The point is, somehow it is an accepted part of our culture that it is legitimate and valuable to keep things. The question is software an object, an artifact of that kind? So, the two issues are simulation and software, and those are museological issues. And as I say, the idea is not to, the idea is to have a workshop, and the idea is actually to try and get two communities to begin the dialogue about what kind of representations could not be made. Right. Why is it that the issue is surfacing now? I mean, why is it that software is a pressing problem? We thought this thing was written, this report in 1987. We formed a software working party under the CCS to look at these problems last year, and the problem has arisen again. There are several factors we can identify. The first is the recognition that software represents a substantial human endeavor. I mean, I don't think that needs arguing for in this case. If artifacts attracted the kinds of resources, either intellectual, creative, or material, and financial, that hardware we would have shrines dedicated to. There is no question that an artifact like Microsoft, which sells 10 million copies, which has massive revenues, involves thousands of people, involves hundreds of man years of effort, if that had gone into a physical artifact, like a PC, there is no question we would consider it by hardware criteria worth acquiring. The second thing is that software is increasingly machine independent, and as such, it is identified as something distinct. The idea that software is distinct from its hardware is emerged in the 90s. Software is a word that came into widespread use by the mid-60s. The very first occurrence has not been traced. By the mid-60s, software was in more or less common currency. And somehow the idea that it is distinct from hardware has emerged, and increasingly so as software is increasingly portable between machines. There's another factor, and that is as hardware standardizes into generic systems, it's a software that increasingly emerges as the arena of significant change. I mean, if we standardize at 486 at the PC level, say, increasingly these things are out of the hands of the major practitioners of the profession. So if you like, there's a pressure group, and I don't mean that in an adverse sense at all, that meaningful effort is increasingly perceived by the profession to be software and systems related rather than hardware. The number of actual hardware designers is diminishingly small. A lot of people are very knowledgeable about hardware. The number of people actually doing hardware design, certain systems design, is relatively small and likely to be involved in special applications. Special applications rather than generic or consumer products. So the invisible pressure group, if you like, is the professional community of hardware, of software and systems designers. And that the profession is increasingly software and systems oriented. And as I say, the major motivation for people to preserve things is to remove symbols or icons of significant personal experience, then it's perfectly understandable that there is a movement by people now active to actually preserve this stuff. So those of you like a lot of contextual reasons, they may sound a bit abstract and removable, you know, what direct pressure does that place us under? But there's something very much more direct. And I've got three, if you like, problems that face me as a curator. I'm sitting as a curator, I'm responsible for the computing collection or the computer collection. And three issues have arisen, which I will use, if you like, as our notional intellectual clients. You know, on whose behalf are we actually engaging in this huge deliberation? We could carry on just collecting hardware, it would rot in stores, or it would be restored, or it would go the fate of most material objects. And there is a serious dilemma. It is a dilemma of action. The first dilemma is shrink-wrap software. A very kind gentleman sent me this, and I don't know what to do with it. It is Microsoft 1. It's the first version, Windows 1. That is the first version of Windows operating environment. For those unfamiliar with Windows, it is the one that changed the, it is based on a system devised at Palo Alto at Xerox PARC in the 70s. It's basically the WIMP system, the Windows icon, mouse, and pull-down menu system, celebrated by the Mac, made famous by Lisa and subsequently Mac, and now cribbed by almost everyone else. There's something like 10 million copies. There's a major shootout between Windows 3 and OS 2. And if anyone told the narrative story about the early 90s, what was going on in the PC world, you would talk about Windows, about operating system. The problem is, what kind of artifact is this? Could I, as a curator, with any kind of responsibility, inventory this? If I said this was a conventional object, what is it? It's a box, and there's an enormous amount of cultural information on the box. Advertising, symbology, imagery, and all that stuff. It is culturally significant. The most significant thing about it is it tells you that it's PC compatible, and that could be highly significant. In it, there are a bunch of books and 9 discs. And the question is, in what respect is this a conventional museum object? Books are things that libraries keep. Boxes and imagery are things that perhaps that curators would keep. But are discs artifacts that would conform to the conventional criterion of a physical artifact? So one is a dilemma, is what, as a responsible curator, would I do? And to give you some idea, okay, for those who may not have seen a Windows screen, that's a very early Windows screen. The idea is you work with icons and pictograms, and you touch buttons to run a calculator, and you have various tools on the screen. It's panned and abhorred by hackers, in which group I include myself, who are used to operating systems where they put file names to do obscure esoteric things. But for people who actually, computer users who approach things for the first time, it is greatly celebrated. And if you like, the community of computer users is split into two: people who are cryptograms and people who hack. I don't mean that majority of hackers, I include myself in that group. To pursue the question of what responsible action could I take, that is an Act of Science Museum acquisition form. I was fortunate or unfortunate enough to compulsory serve time in an army. And so I'm absolutely dead scared of signing anything. I don't sign anything whenever I can. Anything I do sign, I take very, very seriously. Now, at the back of an inventory form, it says, curators, sign receipts, etc., etc. I hereby take responsibility for the objects described over leaf to be kept in perpetuity, in full knowledge that anything up to 3 years after the time we acquired this, that this could be unreadable. In what sense am I responsible for fulfilling my obligations as a curator? So, there is a dilemma. What am I to do with this? In other words, I need to either change my mindset or have a rationale, or if it involves a program of continuous active renewal, that means we must copy that disk every 3 years or whatever, then I need to institute that because those activities and resources do not presently exist. No provision is made for process of continuous active renewal. The model for preservation in an object-centered museum context to place an object in an inert environment to delay degradation. It's perfectly clear that software, in a magnetic medium at least, violates and will not conform or will not survive. Now the question is it any different to a steam engine? I mean, could I, if you go to the welcome gallery, you'll see that all the objects tell you, many of the objects have on their label something about the condition of the object. So it says, poison-tipped arrow, condition poor. Now, would it make sense for me to say, Windows 1, condition poor? I mean, it seems that what makes this Windows is the internal organization of the information on the disk. And as that degrades, does it continue to be Windows? In other words, is its identity something to do with its function, or has information, is information a new category of museum object, which we either need to extend the boundaries of conventional criteria or make special provision for it. So that's dilemma number one. The problem number two is the problem posed by Rob McWilliams. Is he here? Doesn't make about years. Okay. Colleague in the same division as I am, curator of civil engineering. He has a separate problem. Increasingly, he says, the design of bridges. We can't collect bridges. They're too big. Increasingly, what is significant about the process of bridges, the artifact of bridges, is its design, and increasingly that is computer design systems are used. In other words, the story. As a curator, it is required to capture the evolution of technical change. The story will be incomplete unless something about the design process and use of computer design systems is used. In other words, there is an application outside the specific interest of the history of computing to serve, if you like, another colleague or another custodial interest. What advice do we give Rob McWilliams about computer design? That is complex software running on sophisticated, possibly special applications, possibly generic hardware. Are we going to say we can assure him of operational continuity? Clearly not. The resources are massive. What should he be archiving? Will, if he takes a video camera and videos an interview with a man using the system, will it be subject to the same limitations and restrictions as the physical replica? In other words, only the things we perceive to be significant at the time will be incorporated, and it will not be available for the open-ended inquiry, which is what archiving, curatorship, and custodial mandate is all about, or at least as I perceive it. Now, back to the windows. Tim Boone is here, who's our curator of medical sciences. In discussion with him a few weeks ago, I was very struck by the analogy, as he was, the analogy between drugs. The museum inventories drugs, in other words, tablets. Panadol, I don't know if we've got Panadol, but I don't know if there's something called Panadol. But say we have Panadol. Now there's clearly information on the box, it's advertised, it's sold, marketing, support information. I'm quite sure that Smith Klein Beecham, possibly make Panadol, possibly don't, are not going to guarantee the molecular structure that we on its sell by date. Now, in what sense is this Panadol? In what sense does it remain Panadol? For whom is it being acquired? In other words, is this the reference Panadol, like the meter stick in Paris? If somebody wanted to know in 50 years' time what the molecular structure of Panadol, would they come to us? Now, it so happens that in the 17th century, as I understand it, apothecaries, which were actually the origins, conceptually, of museums, were places where you went to get active drugs. In other words, if you wanted an active herb, you'd go to the apothecary, and that's where you went. And the museum idea grew from there. Now, are we saying that if somebody wanted to do an experiment in 50 years' time on the efficacy or otherwise of Panadol, they would come and use this thing? Clearly not. We are acquiring, if you like, a cultural artifact rather than something to do with its chemical potency. And software of that kind, is there enough cultural information on the jacket or sleeve of it to justify acquisition. Clearly, we are not going to renew the molecular structure of Panadol, but we can actually renew the information, the internal information content of the disc. So there are analogies, there are also positive analogies, there are also negative analogies. If a steam engine degrades, there is information in the way it degrades. Curators and conservationists write learned articles about the pattern of bronze and brass as it degrades. But it still remains a steam engine. It's still identifiable as a steam. You say, well, it's a degraded, it's a corroded steam engine. Can the same true be said for a disc? Again, is it right or unlike optic? Right, so we have two problems. Windows, we have the copyright design application. The third one is the Public Records Office application, and I don't propose to say much about that because my understanding of the discussion with Dr. Deeks are doubtless imperfect, and Dr. Deeks agreed to tell us about some of their problems because they have, as I understand, a mandate to preserve posterity, whatever that may be, government records. And the question is, if you preserve a database, do you also necessarily need to preserve the operational environment, which not only gives that information meaning, but allows you to access it and manage it and manipulate it in a way that the original practitioners did. So they have a real live problem, and I'm hoping that Dr. Deeks will actually tell us about that, and perhaps we can get some contributions that we can clearly have some ideas about. So those are the three, if you like, the dilemmas of action. These, if you like, are the intellectual clients for any of our deliberations. Now, it's a vast subject, and I would urge anyone who has any doubts about the fact that there are simple solutions to these things to refer them to the Bierman document. And the most I can do in what little time there is left, happily, you say, is just address two questions, and none of them are very major, and they again to do with the museological and philosophical agonizing rather than to do with practical solutions. The first question is the distinction between hardware and software. This may sound very pedantic, and in fact, having deliberated about it, I came to the conclusion was in fact a pseudo-problem. In fact, it wasn't a problem at all. The question is software, because of its information content, different from a physical object, and that falls outside the conventional categories of the museum mandate? Now, the word software is actually a negative definition. It's to distinguish it from hardware. Hardware you have very little difficulty about, it's so you think. It's applicable stuff. Software is defined negatively. It's the stuff that it actually was not. Then we get things like firmware, which are programs which are incorporated in chips. Now, chips are traditionally regarded as part of the hardware universe. And the question is a ROM, a read-only memory, which has a program in it, hardware or software? And if pressed, you'd probably say yes. So the distinction is not clear. I mean, that just poses an absolutely intractable problem. And it seems that we need to resolve the question of whether software is physical in some sense, whether we can extend the definition of a material object to software before we can actually make any progress. So let me tell you what I did. I looked up the definition of software with enormous ingenuity and discovered the most horrifying thing. This is from the Cambridge University, Oxford University, 1986 Computer Dictionary. Software is a generic term for those components of a computer system that are intangible rather than physical. Now, before throwing out mission statement, the mission statement, this is 1992-93, and is a 3-year program. This is the corporate plan of the Science Museum, this institution. The mission of the National Museum of Science is to be the nation's leading centre for the public understanding of science by caring for, presenting and interpreting national collections, etc. I don't know what the public understanding of science is, and I don't know a man who does. So that's an ideological statement. It's difficult to know what that means. But the really killer is down number 2. Okay, in pursuit of this, 4 objectives are 2. Care for its nuclear collections, okay. Acquire the most significant objects as physical evidence of science worldwide. Now we have a serious problem. We have a definition of software which says intangible, and we have another mandate which says that actually we are obliged to collect objects as physical evidence. So, this is a problem. Actually, are we legitimately entitled under our mandates to collect this stuff, assuming we can have a legitimate rationale for who actually use the stuff and so on. So what I propose to do is this. I have a solution to it. I have, as Baldrige says, a planning plan. That is to use, if you like, a philological distinction between programs and software. A program I would define as a sequence of steps in order to complete a procedure. Okay, so brushing your teeth is a program. You're going to do a set of things. A program need not be recorded. It can be a notional set of things. It may be recorded. You may actually write down what you do to brush your teeth. You may actually write down how it is you multiply 2 numbers, but you need not. I'm saying a program is a sequence of steps required to complete the procedure. And so that software is an external physical record. Software is an external physical record of the program. Yep. And that actually gets past the problem, because the program is virtual, if you like. Computers run programs, we all run programs. It's just a sequence of steps. Whereas if you say that software is an external physical record, it includes the kinds of things we want to include: disks, listings, documentation, languages, examples of the literature, as well as the examples of its grammar, which is how we preserve the language. So, I said it was a pseudo-problem. The idea that the software is somehow virtual and therefore outside the ambit of material culture actually evaporates if you say software is an external physical record. Just in case you horrible scheming people are going to devise a device which says, okay, the disk will say software, this is an external physical record. We'd say that a program in a computer's memory is not software, it's a program, right? Because we'll say it's not an external physical record. It's all okay, it's physical, but it's not external. And that gets by the problem of saying, okay, I can make a device which reads a disk. The disk, we say, so I put it in a device and it reads it into memory. You say, haha, I now have a physical record, which is actually in the RAM, in memory. So, okay, but that's an internal physical record. So it seems that the definition of an external physical record gets past the problem, and we can then say we are entitled to acquire it under normal historical criteria. Okay, that sounds like terribly philosophical and very pedantic. But it's a process that needs to be gone through, because if we are to articulate, if we as computer conservationists are to articulate to the museum establishment what it is we're trying to do, we have to actually come to terms with their mindset, and that is what is our aim. The second question is this: does software place uniquely exacting criteria with respect to preservation of data integrity? In other words, more briefly, do we need if we keep software, do we need bit-perfect records of it? Now, the idea is, certainly, the immediate instinct to say yes. Everybody knows that software is brittle. It degrades ungracefully. The one bit in your boot track prevents you from booting up the disk. So the idea is that if you keep software at all, you need to keep a bit-perfect record of it. In other words, there may be preservation criteria in terms of the total data integrity that may be more exacting than actually the existing procedures or environmental that the media account for, the first determines the media, and secondly, that environmental conditions cater for. So again, is software unlike conventional criteria in that respect? Well, if we think of the Dead Sea Scrolls, we'd say, well, okay, that was data, it degraded, it is a fragmentary record, it is still meaningful and significant. So it seems that not all software, if a disk did degrade, some records are readable and some are not. So the exacting criteria of bit-perfect record in all circumstances doesn't seem to apply. So if you like, very crudely, if we just look at the effects of corruption on program performance, first we have non-critical malfunction. Any PC will have at least 300 print drivers, of which probably you use one. If any of the other 299 get corrupted, we have an instance of non-critical malfunction. It's irrelevant, it will never be evident that this program is actually corrupted. So then we have a situation where a subroutine that is never used, a loop that is never accessed, actually is corrupted and has no practical effect on the performance of the system. The second category we'd like is evident malfunction. The thing doesn't boot, it produces corruption on the screen, it does something clearly that's wrong. You ask it to multiply something, it gets it wrong, it scrambles or text. There's a malfunction which is evident to the user that something is wrong, so you have some warning. The third one is non-evident malfunction, and that is to say, you do the graphics enhancement on the picture from Pluto, and actually it puts an artifact in there which is a white mouse, and you don't know, you accept that. So the danger is that the thing is malfunctioning, and it's not evident. You do a complex engineering calculation, it comes out with an answer, you trust it, and it's not evident that an answer is wrong. And it seems that it is only the third. See, the other two are like other things. They're not critical malfunction. You can say, okay, you've got a steam engine and the bumper fell off. But the steam engine still went. It developed traction. You knew what the steam engine was supposed to do, and the thing fell off. That seems like non-critical malfunction. Evident malfunction is to say that the steam engine didn't develop enough traction. It was slot between the piston and the cylinder. You say, well, that's okay. That's not different. If data corrupts, again, we'd say, well, it's a partial fragmentary record. It is still meaningful. It's the third one that seems to distinguish software from other generic physical objects. The fact that it is not evident that there is something wrong. And that seems to be the problem. And I would say there that if software is, the conclusion clearly is that if software is to retain for operational purposes, you have to have a bit-perfect record. And that may sound like a very trivial conclusion. And there will be all sorts of things, but how can you ensure that? There are techniques that provide global checksums which are unique to that entire global data record, which can verify and confirm whether or not there is any corruption at all. And to some extent even regenerate. In fact, this technique, as I understand, is now used to date documents and acceptable in law courts in America. You know, there's a unique checksum that if there's a date in the document and it is part of the checksum, that date becomes an unerasable, unalterable part of the record. And that is acceptable now in American courts of law. Perhaps this is known, but I was quite intrigued to hear that. In other words, there are techniques to ensure good, perfect records, assuming that is the route we should go. Okay. That's as much as I have to say about curatorial agonizing. And those are just two relatively minor questions, but they are the starting points, if you like, of trying to absorb software into our assumptive world. We can say that hardware, we are perhaps, many people here, perhaps the last generation who had to struggle to absorb PCs into their assumptive worlds. In other words, we were born into worlds without computers, and we had to somehow absorb them and relocate them in a framework of experience which did not include them. I don't believe any more people understand now how televisions work than they did when they first came out, but because they're commonplace, there are less objects of wonder and curiosity than there ever were. In the same way, people born after the 70s into worlds where PCs are taken for granted, there are less objects of wonder that are taken for granted. And I think, if you like, software is now emerging. This is part of the struggle, if you like, to absorb software into our assumptive world, to locate it somewhere in our existing frame of experience, to be able to treat it like other things, and to identify the respects in which is unlike other things, so that special provision can be made. So, if you like, these two relatively trivial and quite, if you like, philosophical questions were part of the process of trying to identify in custodial terms what kind of beast software, what kind of beasts software is. That's as much as I have to say about that. Other than to say, my practical solution for this is to inventory it and to copy the record every 3 to 4 years to buy time. And it seems to be that if we do that, we keep all options open. We don't send the book to the library, we do keep the box. And I don't know of any PC that ran generic or consumer software that we cannot get and make work. And so while we have the CCS and while we have the possibility of operational continuity, it seems we don't have to face the major issues of maintaining operational records of software. Right, that's as much as I have to say about software. There's much more interesting stuff to follow, and that's the things of simulation. And again, the issues are, is simulation and emulation, and we can perhaps tease out the differences between the two, a significant factor in the idea of keeping, firstly, the operational persona of the machine. That's a term that Tony chose, and I think with great judiciousness, because a persona, as I understand it, is actually an actor's mask. It is the way an actor appears to the world, and the persona of the machine is precisely what we're recreating. This is not Pegasus, but it creates the persona. It behaves as though it is Pegasus. So the question there is, if we can eventually untether ourselves from the attachment to operational contemporary hardware, whether simulations or emulations of this kind actually are the future for preservation, including software, because we can now run software and emulation, and we can retain, but we have the hope of actually preserving stuff indefinitely. The second issue, of course, is a more philosophical one, and that is the one I mentioned earlier. That is the logical implications of whether simulation and emulation are logically distinct, if you like, from the process of physical replication. So with that, I'll hand over to Tony.
Follow that, as they say. Well, thank you, Doron, for that. That certainly set the scene, and there was a lot of questions that are going to keep the CCS occupied for some time to come. Radio mic. Not hearing me from you, Doron. My thing is really in two parts. First of all, I'd like to introduce the Pegasus simulation and explain a little bit about why we did that, or Chris Burton did that, and what we think we've achieved with it. And then I'd like to show you a simulation of another artifact, which just happens to be unveiled there, which I'm sure some of you will find extremely interesting, but more developing the theme of how we actually do articulate objects using the sort of technology that we've been developing for this simulator. Could we have these slides, please, Pat? Okay, if we take the video off, that's it, right. So there's Pegasus. That's a slide of Pegasus. And you can see alongside here the actual picture of Pegasus. And when you come up and have a look at that after the talk, you can see how extremely accurately Chris Burton has put all the detail into that simulation. Now if we could run the video, Pat, we'll just show you a short video of demonstrating the simulator. When we get the right buttons pressed. We need to just dim the lights as well. We have a problem, I think. We did have it coming shortly. We've been trying to do very clever things. It's always a bad thing to do that with technology, as we all have. We've been trying to switch between the computer output here, which I want to show you, and the video. And we seem to, at the moment, have lost the video. We'll be there in a moment. The idea for doing this simulation of Pegasus arose quite early on, and it was a conscious decision. I think it sort of arose within the group of people working on Pegasus that we felt that having got it actually working, it would be useful to have a representation of it and capture the working machine. The point is that people in the past have written emulators, and they've done that in order to run code of a later machine, or an earlier machine on a later machine. That's been right from the very first machines that were ever built. But they've always been black box emulators in the sense that they would just run the programs, but none of those early ones were in any way interactive. And what makes the difference now is the ability to have interactive, high-quality graphics on affordable computers, which gives the option of being able to write a simulator in front of an emulator. And we have just made the distinction between the emulator, which is the logical emulation of the functionality of the computer, and the simulation, which is the human interface to the computer. And it was Chris Burton's idea of putting these two together which really gave us this leap forward with the production of the simulator for Pegasus. And we've still got a problem. Why my tape? Maybe with you. All right, all right. Okay, I'm talking. Right. Now the thing is, having done this and produced this simulator for Pegasus, as I say, what we realised was that just writing an emulator from the published data about a computer has been done previously, and that was done by Martin Campbell Kelly. Right.
Society is the role of software emulation on modern computers of the early computers. Two reasons.
Bring your stand up,
One is a way of preserving the way you operated the old computers, and secondly, it's a possible way of training newcomers to conservation, in particular people of the future who are going to look after our facts that exist at the moment, how to operate the machines, bearing in mind that you do need a fair amount of hands-on I'm going to do now is load the program. We'll load this program, which is going to calculate and print prime numbers. And this particular program was in fact written back in 1959, I think. And so we have the original paper tape, copied a number of times, and now transcribed into the machine, and we can actually run that original program tape on the simulator. So I'll load that program, put it in the tape reader, come across and say the system reset, and now using the initial orders which are on the simulated drum in this simulator, we can assemble a program which is on the paper tape. And that's happening now. So the initial orders in the machine have been fetched off the drum. They're being executed in the simulated computer. They're reading the paper tape, assembling the program that's there, giving some punched output as monitor information. And over on this monitor, for example, we can see the current instruction which is being executed. See which one's running, which is up there. The program's running in, and we get confidence that it is going in as the real tape gets smaller. Now the program loaded, and a typical happening that with Pegasus, so-called 77 stop, program stop, neon light appears here. The instructions have told the operator to load the second tape, which tells this program how many card numbers to display. And we'll choose 100. We'll display 100 card numbers. So I select this tape, tape reader. Go back and run again. That is the tape ready. And we stop again just to get a setup and off we go with the run. Now this is the prime number program which is actually running in the emulated Pegasus. It is producing results on the paper tape. They haven't come through to the total yet. It's early information. Now here we go. Prime numbers being generated by the emulated program. Naturally, it speeds up as it gets nearer the end, sort of few of the trial factors try. And we've now finished the program. We've only got 53 here. Of course, there's a lot of numbers still waiting in the tape there. So if I just go up and run out the tape, we'll see the remaining numbers. Finally, it says the number of numbers are specified by numbers. So there we have a complete program from the 1950s running on this emulation of Pegasus. And clearly we think that this is going to be quite a useful way to train people on how to use the machine in the basics of it, at least before they get access to the real original Pegasus.
Okay, thank you. That's the simulator then, and that was a demonstration by Chris Burton, and I think he really did an absolutely fabulous job in producing an emulation of that quality. Thank you very much. That was an eye-opener to all of us. We'd all sort of vaguely thought that this was possible, but to see an emulation of this quality, a simulation of this quality in front of a bit level emulation was a major mind opener, and it made my mind turn towards the ways in which we might be able to carry this forward as a technology from the computer profession to help possibly other professions in their work with other objects. And so when, as some of you know, I've been involved with the Bletchley Park project to save Bletchley Park and recreate the cryptology, recreate the cryptology museum there. I was brought face to face with the Enigma machine. And here is one of the actual German Enigma machines from the Science Museum, which Derek Hudson has kindly brought down from the display upstairs. And my idea was that one should be able to create simulations and emulations of machines other than computers. And so what I set myself first of all was the task of producing a simulation of the action of the Enigma machine. And that was done using a home Amiga computer, which is a relatively cheap computer, but quite powerful with its graphics. And after some considerable sweat and labour, using Modular 2, Chris used Terra Pascal, which is probably a better choice, but Modular 2 has some advantages. Not very many, but it took me a long time to do this because the problem of, whereas Chris was painting his objects, one object at a time, on here. Every one of these, I think, Chris, is a separate statement of part of the picture. What I was interested in is the possibility of animating a picture. And so my task was to find ways of picking out parts of a picture and making it animate, and then constructing the emulation behind that so that the whole thing would work correctly. And so I had to write this in Modular 2 as a series of parts of picking up graphics and moving them around. Now this is the simulation of an Enigma machine. If you press a key down, then the appropriate enciphered lights up there, lamp lights, and that's pressing down the A key and the Z lights, and then the wheel on the right-hand side goes round one position, and when you press it on the well-known message ASDF, you get R for the second one, and K for the next one, and so on. And that is enciphering the text, and in the operation with a German operator, they would in fact have two people, one reading the text and keying it in on the Enigma machine, and the other person sitting beside him writing down the lamps, lips, which the operator called out, and then it would go to a radio operator to be sent in Morse code. Now, what I wanted to be able to do was also to be able to take the machine to pieces and unpack the wheels, take all the wheels out, and then be able to reassemble the wheels in different orders. And we'll just use that well-known order. Whoops. That well-known order. We have a problem with this. No, we don't. Sorry, that one. Okay. Put the wheels back in again. Then close up the wheels and close the lid. And then you have to then set the wheels, so you open up the cover in front of the wheels, and you can then rotate the wheels with the thumb top in order to set the wheels to the start position. And those of you who can see this here can see that these are the wheels here that you turn around by hand through the top of the lid there. And again, just for interest, this is the I mean, there is another lecture which you won't get tonight, which is how the Enigma machine works. But that is the initial settings sheet, a genuine German initial settings sheet for the 2744, and that tells the operator which wheels to select to go in the machine, and then the ring settings on the wheels and the steckering, and then it tells him the possible start sequences that he can use, the different nets within his network. So that is the way the machine is set up. And what was interesting was when we were running an open day just outside Bletchley Park, and I had an Enigma machine alongside me and this model, and I had crowds around me all day because I was showing them exactly how the messages were sent and set up and operated on the machine, and doing it on a model. And the point is that the Enigma machine was behind a glass case, so we don't want children's fingers all over it, obviously because it's very rare artifact. And yet they were able to relate sufficiently to seeing that model being operated, seeing the simulation being operated, to completely understand how the Enigma machine worked and what the procedures were. So that was an emulation, a simulation of a machine other than the computer there. Now, the next question was, how do we actually animate that? And the way that is animated, that first one was done with program, but that's not the right way to do it. As computer professionals, we should be able to give potential users of a system like this a much more user-friendly interface and way of animating objects. And I felt, together with some other people, that we should generalize this to be able to offer curators the possibility of animating objects other than computers. So this was my next attempt here is an attempt at a methodology for actually animating. And the first thing to do is to use a paint program, of which there are many. This happens to be dPaint 3, in order to set up the basic pictures of what you want to animate. And so this program enables you to draw. It enabled me to draw a picture of the Enigma machine first of all, and being only just a single floppy disk system, it takes a little while to load in. This happens to be a very big program. Right, so now we can load in the images which were used to generate that picture, and so these were painted using this paint system. Sorry, not paint. So you first start off by either frame grabbing from a video system or just doing it the hard way as I did, just painting it. And you start off with a basic image, which is your first view of the whole thing that you're going to animate. And so there is the basic picture of the Enigma machine, and that's your starting point. Now what you want to do is to animate that, and there are various ways in which you can perform the animation of that, and in the Amiga system they're called gadgets, and each of the computers has their own way of describing how they handle these various things, but they're in the Amiga system they're called gadgets. And what you need to do is to define, first of all, what's known as a hitbox. You need to define a hitbox. That is where when you put the mouse pointer on and press the mouse, that's the pointer. You need hitboxes, and then you need to be able to cut out parts of the image in order to make the various pieces that you want to work. For instance, you need to cut out a key in order to make that animate. You need to cut out the top cover there, and now when you've cut out the top cover, you really want to be able to show something underneath that. So the next stage after producing your drawing of the complete machine is to start producing drawings of what you would see when you open up the machine. So if we take that one out there and load another one in here, 6D, and you can now see, if you watch carefully, that in this case the keys are down, whereas before they were up. And the previous lot of keys have a little stalk underneath here, and these have all been moved down up within this picture. And what's more, this shows what would appear when the cover is lifted up. So you now produce a number of drawings, modifying in each time the details of what goes underneath different layers. So that's the way you produce the parts of the picture. So how now do you animate it? Now we come to the next bit of the puzzle, which is to have a system which enables you to animate pictures. And this is what I've been playing around with in odd evenings when I can get away from doing things around the house at home. Now, this is now the system building system for building the animation of objects. And this is using a database system called Metasys, which I wrote many years ago, and I've just rewritten into Module 2. It was about 30,000 lines of assembler, and it seems like the same number of lines as Module 2, I'm not sure if I didn't quite. Now, the point is that if you want to, when you run this system, you want to be able to specify the various parts of the object that you want to animate. First of all, I'll just run this to show you the next picture I'm going to show you now has been entirely generated, not by hard code as the first one was. This has been generated by this method of interactive cutting of images. And this is the same model of the, a similar model of the Enigma machine, but done in this other way. So, what I'm showing here is the different ways in which you want to activate an image. When you hit the mouse button on a spot on the screen, you can have a normal image which is normally shown, which changes to a new image when hit, or, and that's this case here, or you can have a piece superimposed on another piece, which is the key going down, which I'll show you animating in just a moment. But just first of all to show this one actually is very similar to the first one. There's the opening of the thing, and there's the opening of the wheels, and there's the unpacking of the wheels. That's as far as this particular one goes. But that shows that this particular technique is capable of doing similar sorts of things to those achieved with the hard-coded version. And that is all running interpretively under data dictionaries in Metasys. Now, what I can also do now is to animate. You see, that at the moment, that key is not animated. So now I'll just quickly animate that key to show how the thing works. So this time I want to activate, and I want to activate Enigma. In a final system, a lot of this verbiage will be hidden. You have to specify the first screen you're going to start with, the first image you're going to start with. It needs a text file read system. Right, so now that's now entering the activate, and it presents you with the first image, and then it presents you with a list of options. And with using this, you can change the background screen, which we don't want to do. Now the hitbox name, I'm going to call that with great originality key Q. And now I want it to be rendered with Enigma dot Q up, which is the up image. And then when it's hit, I want it to be rendered with Q down. And that is going to be in the same render position as Q up. And you're going to take that from Enigma 6D, which is the image which contains the down keys. Right, now it hasn't got the messages that it should have, but it's now waiting for me to define the hitbox. So I now define the hitbox. Can you see that on the screen there? Yes, just. That's defining the hitbox there. Now I define the image area that I want to activate. I put a box around that as well. There. Right. Now that goes away and creates the data dictionary entries for the images, saves the images, and puts them into the data dictionary and constructs the linkage there. It then changes to the down key position, takes the image from that, and adds them all together, and then goes back and says, do you want to do anything else? We won't do anything else now, because time is short. So we go back to the main thing now, and if we now run that activation again, we have now added that key to the active list. I'll give them a fair downwind. So, I mean, that's a very trivial one with the key, but the whole of that previous activation that you saw was done using this cut and paste technique, and that removes the problem of having to handwrite the code as to where each image has got to go and how it's got to be strung together. So this is a step towards providing a tool set, and Chris and I have had long discussions about the right ways to do this and how we should take this forward. But it is steps towards providing a tool set for non-computer people to be able to activate and action images. And I think this is quite important because in museums there are lots of objects which you cannot let people play with. And this provides a mechanism for enabling somebody to have alongside the real object an activation and actually make it work. So now, just to prove that we're still back where we were, that's still open and closes there. And now the key goes down there as the key is, as we put the mouse button on it and press the mouse button. So that has added an activated image to that image. Well, very trivial, but it's a step, we think, in the direction of being able to make the activation of images available to a much wider audience. Right. That's it very quickly. And now I think, Doron, it's really back to you to how you would like to move forward on opening up to other parts of the discussion.
One is I'd very much like to hear about the PRO, and I suspect others might too. So perhaps if we have, say, 5 minutes of questions, and there are any, it's not just about the PRO. If anyone wants to raise anything now about either of the two curatorial agonizers or these wonderful machines, let's at least get something cracking now. Silence.
Can I just throw in another dimension to this problem? Supposing you take a piece of software like the IBM MVS operating system, which is in many ways relatively invisible. Now, it's one thing taking Windows or Lotus 123 or something. You can see lots of ways in which you can do that, as has been discussed. But I wonder whether something like the MVS operating system, whether you have to say, well, it's just too difficult a problem, we'll just forget about it, or what? Any suggestions?
Yeah. The software, when I said go around block times, the conclusion almost everyone comes to is that the problem is intractable. The reason I chose the 3 samples I did, one is because it seems that there is something positive we can do with respect to consumer shrink wrap software on the Lotus PC style, because we can ensure continuity of operation. The advice, if Robert Williams, which is roughly the same category of example you're raising, came to me and said, I'm terribly sorry, there's something we can do. That I don't see a way without massive resources. And the question then is, what is the rationale for justifying that? I do not see how it is we keep old mainframes going. I do not see how we can keep operating systems going. Once we can create a justification for keeping application software going, then what follows from that is you need to keep the contemporary synchronous software, the invisible stuff, the operating system, the particular release, the particular set of patches, and all that stuff. I think the lever, it seems to be, is we can do a holding operation at the PC level. I still feel that the next level up, which is special application software, complex software running in generic or big systems, is just intractable. We have a Cray that Peter Bales negotiated the acquisition of, it is inconceivable we'll ever run the array. We have a CDC 6600 CPU. It is inconceivable we'll ever run that machine. The beauty of these simulations and emulations is the point that Tony makes, which I think is very, very valid. The simulation by itself is subject to all kinds of objections about authenticity, about open-endedness, about the integrity of the model, and all the rest of it. But what Tony says is that if you run the one, if you right next to the other, so you've got the benefit of the physical artifact and its operational thing, and you run while you can run the old one, you use it as a performance benchmark. And I think there's something far more than just two machines emerge. You actually have somehow the one validating the other. Ultimately, sad as it will be, I cannot expect Pegasus will be running. Ultimately, Pegasus won't be running. And it seems that what we need is the stepping stone, the transition. While those machines are running, we extend the operational life beyond perhaps their commercial life to the point where we can actually do simulation and emulation. So I think we've made a major step in conservation preservation. To me, the problem of what we do with the big systems is as intractable as it was when we entered the whole thing. I don't know what to do about it. We can keep the big artifacts as icons, as symbols, but there will be no difference from ordinary artifacts, and possibly a lot less informative. I don't know what the answer to that is. One answer is to video applications, which is something that is again being pursued, and that is to video people in their application. And that is perhaps something one can do. So, okay, this is what it was like. But then again, that will be through the windows of our particular perceptions at the time. It has the same limitations as physical replicas. We can only incorporate the parameters and predicates we perceive to be physically significant. We would not have put Mercury in Faraday's workbench. So I think that's one step forward, but it does not have that. Keeping the original artifact in material terms is the only psychologically satisfying course of action in response to the open-endedness of human inquiry. And it seems short of complete operational integrity, you can't preserve that. It looks like we're going to have to settle something else.
Well, surely it's just a question of large dimensions. Can't you just emulate the basic machine, basic mainframe machine, and then patch in the operating system onto the emulation and same
In principle, I don't see why not. Perhaps there are people technically more.
It's a quite sensitive question.
The problem is the justification of resources. See, what's extraordinary here is the bootstrap arrangement. Chris Burton's deep knowledge and commitment, and Tony's deep knowledge. And ultimately, it's something I mentioned earlier this afternoon. History filters out what ultimately survives, and mainly it's debris, it's physical debris. What we're in a possibly unique position is that we have generations of people who are involved in these things who actually care enough about machines to preserve them in this way. But if it weren't for Chris Burton's attachment and commitment to that machine, Tony's involvement, and our, the creation of the C system is a volunteer body, this conversation wouldn't be happening. Ultimately, by default, all that will survive will be physical debris. Pegasus would not have its emulation if it weren't for this particular group of people. So it's yes, in principle, absolutely. The question is, how do we justify to the existing custodial establishment that this is something absolutely worth doing? If they should spend, it's going to cost £100,000, or certainly £10,000. Why should they commit this rather than to build a new hangar for another 100,000 objects? That's the kind of argument we're getting to.
Well, on that very machine is in fact an example of just what we've been talking about, which is Joan Ripp's public domain emulation of the Z80 processor chip on IBM PCs and the CPM80 version 2.2 operating system, which I have with me if people want copies of it. And that the only difference between that and the IBM 360 MBS operating system is one of scale. And the IBM MBS operating system is much bigger. It's not hugely bigger. It is much bigger. It's not hugely bigger compared with the kinds of machines that are about to become PCs. So that seems to me to be a quite tractable problem. I wanted to go on to a more deeper sense to take issue with the way of Doron, is that I can see why, because of the museum's mission statement, we should wish to introduce the word physical wherever it can be introduced. But in a sense, that isn't where the answer lies. The answer lies in something that represents pure information, which various names have been given to information space or cyberspace, the name has been given. I mean it to be information divorced from any particular medium. And in a sense that's been around for a very long time. For example, there are no doubt
hundreds or possibly thousands of performances of Shakespeare's plays every week or every day, and very few of those are by reference back to original copies of Shakespeare's Holy. But the works of Shakespeare are pretty safe because they're disseminated through thousands of representational copies which are, in effect, representing information. The media are irrelevant. And that is where the answer lies with the software and the data and processes that make it all have some kind of meaning. To circulate and store the information on whatever media are convenient at any given instant. And next day, maybe next month or next year, some other medium. Not an object-centered vision at all.
Actually, that's a point which I think would be very appropriate to bring Dr. Higgs in, because I think that's precisely an issue that's been faced. I think you've chosen optical media. I wanted to, can you tell us perhaps what's going on with Doron and what your...
Shall I come to the front?
Please do.
Yes.
Yes.
When I came here tonight, I didn't realise I was going to actually be asked to speak. Literally on the back of an envelope. Right? I didn't realise we were going to get into Gadamer's hermeneutics either, so this is what I think you're talking about. But I'll leave that out. I work at the Public Record Office, which is the National Archives. And we work under the 1958 Public Record Acts, which basically say that we are responsible for all objects in government which carry meaning.
So what do you do for the rest of the week? Yeah, that's right.
What objects don't carry meaning? We've obviously got a problem there with machine-readable data, which in theory we're supposed to be keeping forever. And I'll repeat that, ever. Rather peculiar concept. We were working on this for about 20 years and never got anywhere. Mainly because we've got terribly hung up on the idea of taking in data and somehow preserving its functionality. That is, preserving the operating systems along with the data, so that departments could take the stuff back and process it. And of course that's totally impossible because we don't have the resources to preserve all software. So what we're talking about doing now is essentially getting data. We're talking at the moment simply about structured sequential data in our databases. Getting departments to dump it down for us in a sort of report format or mask or something like that, which we will then preserve on Laserdisc using cold technology, feedback to Laserdisc, which is the sort of stuff that it's used in banks for logging transactions and supermarkets. The problem with this is that in just keeping the data, and not the functionality, as it were, of the original system in which that data sat, we've destroyed the context in which that data was collected and used. Now, archivists are very concerned not just with artifacts, but with the concept of process, which created those artifacts. Because for us, that puts the artifact in a context. And the way in which data is manipulated, or changes in the way data is manipulated, can actually very much affect the nature of that data. My particular interest is 19th century census data. And in the 19th century, you have all these nice, very simple enumerators books, where the census enumerators collected household schedules and copied them into enumerators books, which were then sent to the census office in London, where the data was abstracted and tabulated using very large tables with various one variable on one side and one variable on the top and that sort of thing. Suddenly in 1911, you get a vast mushrooming of the number of questions that are asked, particularly concerned with the 1911 fertility survey. And you also get, rather than the enumerators books, you suddenly get the household schedules bit easily, which is going to create a dig into the job of the archivists when in 100 years' time, or 100 years after the data is created, it becomes public. Now the reason that happens is that in 1911, the Census Office for the first time uses a computer to tabulate the data. They got some equipment from the British Standard Tabulator Company, which is the forerunner of ICL. And this materially affects, therefore, the nature of the data. And it's therefore important that historians, when they get this data, understand the changes in the data processing system, so they can understand the changes in the data. But, going back to our machine-readable data archive, if we strip the data off the actual applications on which it was run, we've removed that data, we've removed some of the context. And there's all sorts of questions that historians might want to ask about the original applications, which might explain some of the structure of the data. Why are there certain limited parameters in particular fields? Why has data been collected in a certain way? If data has been enriched, enhanced, or combined, how was this done? Does it reflect the original purpose for which the data was collected, subsequent manipulation, or does it simply represent a limitation on of the computer software which was being used to manipulate that data? So from our point of view, it would be very useful if we actually had simulations of what the original computer software was actually doing, so that historians can go back in 100 years' time, when some of this data becomes available. In the public record office, you often close information for 100 years if it contains personal details of people's names. People will be able to go back, I imagine, if you've got this software, and see how people were actually manipulating it, what you could do with the system, which might explain some of the peculiarities of the data. To give you an example of some of the problems we've got in the archival world, totally separate issue, automated office systems, which you can imagine a civil servant sitting in an office somewhere, assembling data on the screen, or information on the screen, and then on the basis of that information taking a decision, but not saving the information that appeared on the screen. What that means is that your administrative process disappears. You no longer know how and why a particular decision was taken. What that springs from, I think, is the dissociation in computers between a storage medium, disk, and the place where you actually, the medium in which you manipulate the data. And this is very much like what conventional archivists are used to in the Middle Ages, where the medium of manipulation of information is the spoken word, but the medium of storage is the parchment, document. So in a sense with computers, in our field, there's a great danger that we're returning, as it were, to the Middle Ages of information. So, going back to where we started, from our point of view, it would be very useful, I think, if we had some examples of the original software functioning, so we could get some idea of how people were actually using the data, which would put the data which historians may be using into some sort of context.
At present, are any measures being taken at all to retain or store or archive the operating software?
No, that's right. I mean, there's no, at the moment, there is no, within government certainly, and that probably means everywhere in this country, there is no archiving of machine-readable data going on at all. And indeed, there isn't any archiving of this sort going on in the world. The Americans and the Canadians are getting towards it, but as yet, there doesn't seem to be a machine-readable data archive up and running anywhere in the world, certainly in the government sphere.
Please, thanks very much. I mean, let's throw it up. We've got, a few minutes till 7 o'clock. Please, anyone who wishes to raise anything. I don't know if perhaps there's someone who's seen more information than I have, but I saw an article about what's called optical paper. That is a polymer developed by ICI. It's stored 4 megs in 1 square centimetre. and its recommended life, its known working life is 15 years, and when tested complete, they reckon it will be 50 years. So they're talking about basically laser written, what they call in paper, but it's actually the same polymer that's used in the back of make tape, but it's laser written, it's non-contact read, and this is now this is a product which is now in its testing phase. Christian, what have you heard about it?
It's been going for several years, and I think what had to be taken off was the inertia of having to install read and write, of course. But what you say is quite correct. It's thought to have a very long life, very, very high density. I never thought I would need this for that application.
What struck me about what I read was that they were boasting of 15-year life. When I was in the States in '82, I went to a seminar run for bankers by an information expert who, in response to a banker's problem, which means they had buildings full of floors which were sagging with their archival tapes, the consultant told them to throw them away if they were older than 3 years old. And by law, you're required to keep financial records for 7 years now. And the manufacturer did not guarantee magnetic media. It can't be magnetic media for longer than 3 years. And what I was struck by the optical tape was this is supposedly the utopian solution, and they're promising a present 15 years, possibly 50. In other words, we're talking about magnetic media which are vastly impermanent. I'm very struck by the fact that this medieval situation where, although we're in the information age, in fact our records are less permanent than they've been before. Information is supposedly vastly important, and yet there is less permanent record than there has been. And it seems that this is the case, this is very much the case.
There's a very great danger of preserving the trivia.
Yes.
I mean, there are other things like CD-ROMs that store 600 megabytes of data on a little flat thin disk. And that's, you know,
I think
that has a long life. I don't know why.
How long is your CD going to last? I mean, again, people have said it will only be a few years, and they don't know the effects, for example, with music CDs, the effects on the plastic of the ink that they print the advert on the back with.
As far as potentially in data storage goes, I don't think there's an ultimate problem, because ultimately when dumped on paper, the best preservation techniques, the most archival knowledge, preservation knowledge is about paper. We can preserve paper almost indefinitely, and it's perfectly conceivable to produce a bit-mapped record on paper. So the question of the permanence of the medium, I don't think is an issue in principle. The problem Dan was mentioning about CDs is basically, can you guarantee the continuity of delivery medium? And that problem with CDs applies to the same generation of computers, which will renew itself. So I don't think it's a question of, the question is what rationale we do, what selection, what data would we keep? The problem about data itself, I think, is the easy one, because we can use optical tape, we can use CD-ROM, we can use various things. The difficulty comes when you start changing the host medium of the operating software. Because that becomes dependent on a whole pile of other things, like machine-specific BIOS, for instance. Like the fact you may have overlay files which are part of the operating system, and access to particular physical parts of the disk that the correct operation becomes dependent on the actual physical format of the data, and then the bulk transfer from medium to medium, optical disks now, subsequently that becomes a serious problem. And actually, what in fact are we preserving? And anyone who knows about the patches, I mean, there's a bug in the hardware of the XT UART, which has been written around by IBM in their DOS. And if you mix the wrong DOS and the UART, you're in trouble. Now, where are these patches? Where's the information about the patches? And we're talking about software being portable between machines, but we've got software that is not upwards compatible from release to release. So when we're talking about raw data, I don't believe is a problem. We can access the stuff provided we have enough contextual information interpreted. Operating software is a totally different problem, and is intractable. Because for all the technical reasons, and that is something that really needs to be thought through. Part of the starting point of this whole thing is that I mentioned we've gone around the block, we have the software working party, and it's part of this yes but thing. And somehow you feel that you want to go and sit quietly to think it through, because somehow you can create a landscape where you can locate these various positions. That was my starting point. Part of the reason I sort of committed and thought this might be a good idea, because I used it as an excuse to go and sit quietly. Well, the opportunity didn't arise. And if there are instincts amongst people present are going to quietly think through, please do, kind of tell us what the result is.
You're emphasising the difficulties with the operating systems. There are a few intractable bits which you can mostly get around. The great majority of it is not there. And on the whole, things things are moving towards portability and generalisation. And I still think that there are not too much physical object centred. The thing is to throw the balls in the air and not let them come down. Keep them flowing, whatever the media of the day is. And in passing, I would also remark that, as you know, that the impermanence of magnetic media at the moment greatly exaggerated.
Yes, it's a question of guarantees. I've got this running 15 years old, only 10, 15 years old, no problem. The question is, what's the guarantee? To what extent, if you had a renewal cycle, what would the minimum guaranteed renewal cycle be? And manufacturers are notoriously wary of making commitments. I'm interested to know whether you can get a manufacturer to commit to data integrity after 5 years. 5 years is probably quite fine.
I was at the Royal Greenwich Observatory about a month ago talking to the person that comes there, the computers there. He was saying he's got his tapes, for 30 years.
Nothing is totally permanent. I mean, there's an ambiguous.
But I thought that was a bit like a man sort of jumping off a skyscraper halfway down saying everything seems okay.
Right, I think we'll draw to a close there, and thank you all very much and all the contributions. And as Doron said, this was a workshop. We hope it stimulated thought and discussion, and we want to continue with this because I think that the Conservation Society has got a positive contribution to make to the museum, and I hope the museum will be receptive to our endeavours. Thank you all very much.